LeetCode out here thinking it can stop me. You can't. You can't. Bro, no matter what problem you throw at me, as long as it's a medium and not a hard, I feel like I can crack it. Same tree. Given the roots of two binary trees, P and Q, write a function to check if they're the same or not. Two binary trees are considered the same if they're structurally identical and the nodes have the same value. Oh, so they have to be structurally identical. So it's not just the list equivalent of it can be the same. Okay. So I'm thinking we do a little. Actually, let me write out the solution. We know what an in order traversal is, right? We want to do an in order traversal of our array, except at the parts where we no longer have a node, we instead of just returning nothing, we want to append null just to show that at that part we have nothing, right? So initially with like an in order traversal of, example one, we'd get 1, 2, 3. Want this type of representation where there's a null wherever we don't have a child. So I'm saying if the node is none, add a null there. And if both your children are none, don't even go to the subcase. All right. I'm cooking. I'm cooking. Don't even stress, because this is the definition of someone who's cooking. In order is going to take in a node, which is an optional tree node. And all it's going to do is call if node in order on node.left, node.val, in order node.right. Correct? Now, technically, we could call this the p results equals, actually not equals, I just call in order on p and pres. And for those of you who are wondering, hey Anish, what is pres? Boom, defined it. Let's also do a qres. And let's do the same thing for q and qres. Now the only condition we have to add before we do return pres equals qres is I'm going to say else. So if it's not a node, else node res.append null or none. It's missing a res. Of course it is. Anyways, pres, and then let's print qres. Yeah, the node.left or node.right was a little unnecessary. Also, this list representation could look a little confusing, but the nuns are basically where the children are none. I see what's happened here. How about we flip the order? That way we have our parent node coming in first, and then we do a little in order on both sides. Boom. That's what they don't teach you in school. The reason is, otherwise, we would have node.left, subtree, come up, then node.right. But why wouldn't that work? Let's go back for a second. Because the left subchild is 1, its child would be none, 1 and then none. We come up 1 and then none, which would be the same as doing none, 1. Boop. None, 1, none. Okay. Yeah. Basically, if we follow the questions binary search tree representation, sorry, binary tree representation, where we start with the parent and then left, right, we won't run into that problem. But yeah, thank you all for watching. Hopefully, this was a useful video. And have a great rest of your day.